Okay, I have a question here about a problem. It looks like this. We have x cubed plus 2x squared minus 5x minus 6 over x squared minus 4. And the question here is, okay, about intercepts and vertical asymptotes and removable discontinuities or holes in the graph. Okay. So the first thing that we need to do is we need to factor these things. Okay, this is a rational function, quotient of polynomials, so we need to factor it. Okay. Now the bottom here, pretty easy to factor. X plus 2, x minus 2, right? But the top, how do you factor that? With a calculator, okay? So I factored that as x plus 3, x minus 2, and x plus 1. Okay, so this is our first step function factored, right? Now we want to look at any common factors that we have on the top and the bottom, and you notice that here we have one that is identical, right? X minus 2, both factors of the numerator and the denominator. We can cancel this, okay? So there is a removable discontinuity or a hole, okay, in this graph here at x equals 2, right? We said x minus 2 equals 0. So x equals 2, there's a removable discontinuity. Okay? Now, when we're done with this, okay, what we're left on the bottom is x plus 2, right? X plus 2, there's no way to get rid of it, okay? That's going to be a vertical asymptote, okay? So there's going to be a vertical asymptote, okay, at x equals negative 2, all right? So if you can cancel it, it's a removable discontinuity or a hole in the graph. If you can't cancel it, it's going to be a vertical asymptote. Okay. Now, other questions are x-intercepts. Okay. So x-intercepts. This is where y is equal to 0. So you set this thing equal to 0. Okay. So take this expression and set it equal to 0. Now, a rational function like this is 0. Anywhere the numerator is 0, okay? In the domain, of course. So this thing is not going to be 0 at 2 or negative 2. So we're talking about x not equal to 2 or negative 2 because those are outside of the domain of this function. So those don't count. Other than that, okay, any place this top thing is equal to 0, then we're going to have an x-intercept, right? So we're going to have an x-intercept here at x equals negative 3, and we're going to have an x-intercept here at x equals negative 1. Okay. X equals 2 is not an x-intercept because it's a hole in the graph, right? Y-intercepts, okay, so the y-intercept, this is where x is equal to 0, okay? Notice that when you plug x equal to 0 into a polynomial, what you end up with is this last term, okay? So this is going to be negative 6 over negative 4, or 6 over 4, I think that's 1 and a half. So that's going to be your y-intercept. Okay. So this is how you proceed with quotient of polynomials, rational functions, okay? To find x-intercepts, to find y-intercepts, and to find removable discontinuities or vertical asymptotes. If you have any further questions about this, send me an email.